Welcome to Now UTOKing, a new series of short videos on defining key terms in the UTOK framework. Today, we're defining three concepts: energy, matter, and life. Now, it's kind of a tall order to try to define these big concepts in a short video. My approach is just to define the core definitions that are used in the literature, and then from there, move to the UTOK system and see how they're related in a somewhat different fashion. Let's start with energy. The standard definition of energy is the capacity to do work, but we have to be a little bit more precise. Specifically, we can consider energy as a quantifiable property that is generally conserved across transformations and is recognized both in the capacity to do work as well as in light and heat. The reason that we need to make these specifications is because if you leave it as just the capacity to do work, then you're basically talking about what's called free energy, as opposed to the energy of the whole system. Energy, importantly, is generally conserved, and it's transferable across a wide variety of different mediums, and it's quantifiable. So examples of forms of energy include electricity, magnetism, gravity, chemical energy, thermal energy, and many others. What's fascinating is that all of these can be different forms of energy and yield a quantitative equivalency as you transfer them from one to the other. Another really key feature of energy is that it comes in kinetic forms, which are movements that are actually happening, and potential forms, which are potential movements based on the placement of the object in a field. With energy defined as such, let's move on to matter. Matter is classically defined as anything that has a mass and takes up space. And for our everyday world, we can say that matter is made up of objects. So this chair, myself, the camera, these are all material objects, and that they're generally made up of atoms. They are made up of atoms. They take up space. We need to qualify this a bit, because when we shift from the classical world into the quantum world, things get a little fuzzy. But there are these intermediate kinds of particles called fermions, matter particles. And what they are a bridge from the quantum world into the world of atoms, and then they grow into the world of objects. So fermions have a unique property. It's called the Pauli exclusion principle. And as they evolve from earlier states, what emerges with them is their inability to be jammed together at the same place with the same spin at the same. And what that does is it gives rise to an explosion of volume. This is actually what happened at the Big Bang and caused massive inflations in space and time. So with matter, what we have are mass objects that take up space down into the quantum, where the emergence of fermions, which are matter particles, instead of what are called bosons, which are basically energy particles. So with matter defined as such, let's move to life. Biology is the science of life, and life can be framed as a collection of properties that are exhibited by systems of matter. These properties include things like growth, reaction to stimuli, metabolism, and replication or reproduction. There are various forms of life that exist, and depending on the taxonomy used, in the United States there's a 6-kingdom taxonomy. Often in Europe there's a 5-kingdom, but depending on the taxonomy used, there's different groups of life. And basically, for a non-biologist, what we're looking at are things like bacteria and other single-celled organisms. Then you move into things like plants, fungi like mushrooms, and then finally animals. So, with these terms defined generally, as they are in science, now let's shift to the language of UTOK. We could start with matter, because what UTOK says in its framing, based on the tree of knowledge system, is that we can actually think of matter, maybe using a capital M, as a dimension of complexification. It emerges in terms of the evolution of fermions into atoms, into molecules, then across scale. And what we see here is essentially the emergence of objects that are operating on what we would consider to be the normal 3 dimensions of space and 1 dimension of time. From this, we can say, well, if matter evolved, where did matter evolve from? And the answer, from a tree of knowledge perspective, grounded in cosmology and physics, is that it emerges out of a pure energy information singularity, something that we can call the energy information implicate order. This is the dimension, which we can identify as the Big Bang, which is the idea that if we run the tape back, space and time all get vacuumed back into a pure energy information singularity. We can also see this when we go through the quantum layer into things like quantum foam, where space and time, information and energy all sort of blend together. So the idea here is that beneath matter is the energy information implicate order. And in this regard, we can think about that energy as the ultimate common denominator. That's why when we transfer it through all these different mediums, it's conserved. Finally, we get to life. Life is defined as the set of living behaviors, and in the tree of knowledge, what we see is life emerging out of matter, but to form yet another dimension of complexification. Why isn't life just another jump in relationship to things like, say, from atoms to molecules? The reason, according to the tree of knowledge, is the way in which all of this complicated matter gets hooked together is through information processing and communication networks. This creates a new plane of existence that's mediated by the information patterning flow, and that's what gives rise to another dimension of complexification. So when we put this together, what we see is sort of the bottom layer of the tree of knowledge, which is an energy information implicate order that gives rise to a material dimension of complexification, which in turn gives rise to yet another plane of existence, the set of living behaviors, which are a function of information processing and communication networks. Put all this together, and we have a pretty coherent definition of energy, matter, and life, and how they all interrelate.